Okay, so today what we're going to do is we're going to talk about functions. Now, in pre-algebra you talked about functions before. We're going to talk about it again. We're going to add a little bit to it as we go because there's a few things that we didn't teach in pre-algebra, but we're going to make sure we get that today. So a function. A function is a special kind of relation, which means it's a special kind of list of ordered pairs, okay? Where the x never repeats. That's what you're looking for, okay? The x not repeating on your ordered pairs. So here I have an example of a function, and this is mapping, okay? So 1, 5, 2, 6, 3, 7, 4, 8, these are your ordered pairs. Notice the x does not repeat. That makes it a function. I don't care if the y repeats. I care if the x repeats, okay? And then over here I kind of show not a function, right? 1, 5, 2, 6, 2, 7, 3, 8, oh, not a function because over here I had the 2 repeating. Watch for this. Again, don't care if the y repeats, but I absolutely care if this 2 over here or something else over on the x repeats. When this repeats, it's not a function. When it doesn't, it's a function. Okay? Very, very easy to pick out, but a lot of people get confused on which one's allowed to repeat, which one's not, so watch that, okay? And then they give you a different type of definition. I like mine a little bit better. It's a little bit simpler. A function is a relationship between input and output. In a function, there's exactly one output for each input. They're both good. They're good definitions either way. Whichever one you like, use it. Just make sure you know what you're looking for. So here, as we come up here you can see the domain, the range. This is a function because none of the x repeat. Okay? Then you have the graph here. There's a specific way that you're going to be able to tell. We're going to do what's called the vertical line test. We'll get to that here in a minute. Shows you how to look at a graph without any problems and know right away whether or not it's a function or not. Okay? Identifying functions. Determine whether each relation is a function and explain why. -2 to the -3, 0 to the 6, 3 to the 6, 4 to the 9. But look, none of these repeated. This repeated, again, we don't care if the range repeats, we care if the domain repeats. So this is a function. Here we're going to look, 1, 3, 5, 1, function. I don't even have to look at the range to determine if it's a function or not. I'm looking at the domain. All right? That's the easiest way to look at this. Okay? Moving on. A graph that consists of a point that are not connected is discrete function. A function graph with a line or smooth curve is continuous function. All right, discrete function is where you don't connect them. Okay? You got a graph and you're not connecting them. There's no correlation between them. They're just dots on the graph. A continuous function is when you take and you're actually connecting them through and you have a straight line, smooth line, some type of correlation there, okay? That's what you're looking for. Don't really want to deal with that. Okay. Let's do this one. I like this one. A bird feeder will hold up to 3 quarts of seed. The feeder weighs 2.3 pounds when empty and 13.4 pounds when full. Okay, so they tell you all this information. They say make a table that shows the bird feeder with 0, 1, 2, 3 quarts of seed in it, weighing 2.3, 6, 9.7, 13.4 pounds respectively. So what they've done is they've actually given you your domain and they've given you your range. Okay? So here you have 0, 2.3, right? The feeder weighs 2.3 pounds. So when it has 0 quarts of feed in there, it weighs 2.3 pounds. When it has 1, it weighs 6. When it has 2, 9.7, 3, 13.4. And so they've given you this T-chart where this is your X, this is your Y, this is your domain, range, input, output, independent, dependent. Okay, so here's your range, or I'm sorry, here's your domain, here's your range, let me say it correctly. Okay, that's what you're looking at. Determine the domain and range of the function. Well, there you go. They gave it to you. write the data as a set of ordered pairs. Well, we did that, right? These are ordered pairs. Here, 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 and here. And now you could list it out if you'd like. You could map it, you could graph it, you could do all these different types of things. Okay? And then it says, state whether the function is discrete or continuous, explain your reasoning. Well, this is continuous. Right? It's not just a random set of ordered pairs. These go to what's happening up here, so you're going to connect these. Okay? That makes it continuous when you can connect them. So that's what you're looking at here when you're going through this. Okay? So be sure you can tell the difference between something that's continuous and something that is discrete. Okay? All right, vertical line test, very important. You should know how to use the vertical line. Okay? You can use the vertical line test to see if a graph represents a function. If a vertical line intersects the graph more than once, then the graph is not a function. Otherwise, the relation is a function. Okay, so what do they mean? That means that if you take a vertical line and you move it along that graph, and you take it and you just move it along, okay? And if it intersects anything that's graphed on that line more than once, it's not a function. If it only intersects once, it's a function. Okay, so like this, if I took a vertical line, and a lot of times I like to take my pencil, a piece of paper, something, and go along it. When I'm doing it up here, a lot of times I'll use a ruler so that they can see it, and I go through, and I just come across, and if it only ever touches at one point along that line, at any given time, it's a function. Okay? If I cross over 2 points, like there, whoop, not a function. Okay? Now here, I do the same thing, and you're gonna go, wait, right there, it crosses it. But notice how that's an open circle. This does not include that point right there, where down here, it does. So this is a function. Okay? Be aware of that. Vertical line test, very easy way to see if something's a function on a graph. That's why a lot of times we'll graph things and then draw that line and see where it's at. Okay? All right, then they give you the equation. And what they want to do is they want to say, hey, determine whether this equation is a function or not. And so for this type of situation, later we're going to take this equation, we're going to turn it into, say, slope-intercept form, or we're going to have different ways that we can solve this to determine if it's a function or not. Right now, all they want you to do is plug in numbers to see if it's a function. Now, while I was practicing this, I noticed something about the book, is that right here, they made a mistake. It's okay. This is supposed to be 8. So right here, that's 8. Okay? No big deal. I've got the new edition of it now, and now it's right now. But when I first noticed this on my disk here, that was incorrect. So first make a table of values when they graph the equation. So what they did was they said, well, let's take x and plug it in here. Well, -3 times -1 gets me a +3. Well, what do I add to 3 to get 8? Well, that's my number right there. And then they took another x and they substituted in. 0 times -3 gets me 0. Well, 0 plus 8 gets me 8. And that's how they went about this. And then they took and they graphed it. Okay, notice our graph was correct here. Okay, so they graphed it and they said, well, is that a function or not? Well, it passes the vertical line test when I go through it. So, yes, it's a function. Okay? That's what they're talking about here whenever they give you this equation. Now, later on, again, we're going to see how to solve for it and determine it without actually having to create the t-chart or without having to graph that line. So, be aware of it. That's what we're looking at. Sorry. Okay. So that's how you're going to tell whether or not that equation is a function or not. You're going to plug in points and graph and see what you get. Okay? Same thing down here. I would take in a number, plug it in, which, by the way, not a function. Function, I believe. Okay? So plug in a number. I plug in 2 4 times 2 gets me 8. Okay, fine. If I plugged in 1, 4 times 1 equals 8. Not going to be a function. Okay. Do the same thing over here. Just substitute in, create your t-chart, graph it, see if it works. That's what you're looking for. All right. Then you have all the different ways that you can represent a function. Representation of a function. You can represent it as a table. You can do mapping, equation. Big one we're going to use later. By the way, it is a function. And graphing. Okay? Different ways that you can go through this. You'll be using all of these different ways at different times depending on what we're doing. Okay? Now, function notation. This confuses kids all the times. Be aware. It's not that big a deal. Okay? Don't overcomplicate it. Equations that are functions can be written in a form called function notation. For example, consider y equals 3x minus 8. So, slope-intercept form, it's what you've been used to seeing. Well, now what they'll do is they'll come in here and go, hey, the function of x equals 3x minus 8. Sorry about that, I gotta turn off the phone real quick. All right, so in a function, x represents the elements of the domain, and f of x represents the elements of the range. This is the same thing as saying y. It's basically the same thing. So the graph of x, f of x is the graph of the equation y equals f of x, the function of x. Suppose you want to find the value in the range that corresponds to the element 5 in the domain. This is written as f of 5 and is read as f of 5. The value of f of 5 is found by substituting 5 for x in the equation. What does that mean? Okay, so what that says, if they give you this, f of 5, and this was your function, they're saying, hey, find the function of x when x is 5. So you're going to take that 5, substitute it in, and solve for it. That's all they're saying. It's not as bad as it looks. Okay, so let's take a look at one of their examples on what they did here. They said, well, for the function of x equals negative 4x plus 7. So they gave you the equation, and they said, well, what is it when f of 2? When the function of 2. So you take the 2, and you substitute it in for the x. And this is what it looks like. Negative 4 times 2 plus 7. All they did, it's substitution. We've done substitution tons of times. Negative 4 times 2 gets you negative 8. Negative 8 plus 7 gets you negative 1. So when x is 2, y is negative 1. That's all it is. And they keep, they did that. Okay. This is what I want you to focus in on right now. We'll deal with this other part later. Okay? So here, f of x equals 2x minus 3, find each value. Same thing, f of 1, substitute 1 in for x, and solve. 2 times 1 is 2, 2 minus 3 is negative 1. Okay? It's very simple. Again, these other types we'll deal with later, not a big deal. A function with a graph that is not a straight line is a non-linear function. Okay? If it's not a straight line, it's non-linear. Should know that at this point. All right, so I wanted to show one last thing, but we'll check. Sometimes what they'll do is something like this. If h of t equals negative 16t squared plus 68t plus 2, find each value. If they do this, it's fine. You just have to substitute in more than one spot. It's not a big deal. They give you h of 4, take the 4, substitute it in for the t and the t. That's what they did right here. And then they solved until they got down to one number. That's all it is. Okay. Don't make this overcomplicated. This really is just substitution. I think that's it. Yeah, the rest of it is just checking. Okay, so yeah, be aware of it. Understand what a function is. Be able to identify a function. Be able to use the vertical line test. Remember, a function is just a special kind of relation where the x never repeats. If you have any questions about this, let me know.